Welcome back, focused learners. So, when we hear the word research, I bet most of us immediately pictured the classic cliche, right? Like a scientist in a crisp white lab coat staring super intensely at a bubbling beaker, or maybe someone buried under a mountain of dusty books in some dark library. But honestly, the truth is so much cooler. Research is actually this massive, multifaceted toolkit. It's a systematic investigation for sure, but the specific tools you pull out, well, that depends entirely on what you're actually trying to build or discover. So our goal in this explainer is to completely demystify how we frame these studies. Think of it like becoming a research detective. By the end of our time together today, you aren't just going to know what research is. You're going to know exactly how to categorize literally any study you encounter out there in the real world. Now, let's kick things off with a little puzzle. Consider these four totally different real-world scenarios. First up, we've got a scientist studying why certain plants survive drought way better than others. Second, imagine a startup company developing a brand new biodegradable plastic using plant fibers. Third, picture a teacher trying out a totally new teaching strategy to see if it boosts their students' reading comprehension. And finally, fourth, think about a school actually measuring whether their new anti-bullying program reduced hallway incidents. I want you to just ask yourself right now, do these four studies actually have the same purpose? Are they trying to achieve the exact same type of goal? Well, the short answer is no, absolutely not. And you know what? That fundamental difference in purpose is exactly what makes the world of research so fascinating. The absolute core premise we need to understand is this. Research differs depending on its purpose. Research is definitely not just one giant monolithic thing. It's like a massive puzzle, and it's heavily categorized by what its ultimate end goal is. Are you trying to discover a brand new fact about the universe? Are you trying to build a new physical product? Are you trying to fix a super specific problem in your own workplace? Or are you trying to judge if a massive government policy actually did what it was supposed to do? Pinpointing that purpose, that is the master key to unlocking the entire scientific method. All right, let's jump right into our first comparison, expanding knowledge versus solving problems. This is where we look at theory versus practice. Okay, let's dive into this with our very first category, basic research. Now, you might also hear people call this pure or fundamental research. The defining characteristic here, the thing you really got to remember, is that it aims to expand knowledge and build theories without any immediate practical application. Think of this as, well, exploring the unknown purely for the sake of understanding it. For example, in the STEM fields, researchers might spend years studying the atomic structure of graphene, right? Just to understand its underlying properties. They have literally zero plans to build a smartphone screen or a product out of it today. Or, over in pre-med, scientists might study exactly how stem cells regenerate damaged tissues. Now, to be clear, they aren't developing a miraculous new treatment or a pill yet. They just desperately want to understand the biological mechanism. So there's no immediate solution expected here, but it provides the absolute foundational knowledge that all of humanity relies on. So if that's basic research, let's look at the flip side, applied research. If basic research is all about gathering that raw knowledge, applied research takes that exact same knowledge and actually puts it to work to solve real, practical problems. The whole purpose here is to create useful, tangible solutions that are going to benefit society and industries like right now. Let's look back at our STEM examples. If basic research was just studying those stem cells, well, applied research is the team developing a low-cost, rapid diagnostic kit for dengue fever to improve immediate disease detection in clinics. Or if basic research was looking at atoms, applied research is an engineering team actively creating a new earthquake-resistant concrete mixture to instantly make buildings safer. See the difference? It is all about rolling up your sleeves, problem-solving, and producing real-world innovations. Putting these side by side really cements the difference, I think. Basic research, that is completely focused on theory. It asks the fundamental question, why does this happen? Applied research, on the other hand, is focused on practical solutions. It asks the action-oriented question, how can we solve it? And here's a little secret. You usually can't have the incredible applied research without the solid foundation built by basic research first. They work together, but they have completely different immediate goals. Okay, shifting gears now to our next section, improving practice versus judging effectiveness. Let's look at research that deals with systems and practitioners. And this brings us to action research. The absolute keyword you need to lock in your brain for this one is practitioner. This type of research isn't being done by some detached scientist in a shiny lab. No, it's conducted by teachers, nurses, administrators, or engineers right in the trenches in their own workplaces to improve their own local practices. It is highly localized, small-scale problem solving. For instance, imagine an engineering instructor who realizes, hey, my students are really struggling with creative thinking.
So they decide to introduce project-based learning into their specific classroom, and then they actually measure if the students' innovation scores go up. That instructor is doing action research to improve their own immediate day-to-day professional environment.
And this brilliantly illustrates the action research cycle because it's not just a one-and-done thing. It is a continuous loop. First, you observe your environment and you identify a problem. Then, you plan a change. Third, you act on that plan. Next, you observe the results of whatever change you made. Then, you step back and reflect on what happened. And finally, you improve your approach and literally repeat the whole cycle over again. Actually, I love this type of research because it's incredibly empowering. It essentially means that anyone in literally any profession can be a researcher aiming for continuous, localized improvement. Finally, we reach our fourth and last type, evaluation research. Now, while action research is super small and localized, evaluation research, it steps way back to look at the big picture. Its primary goal is determining whether a wide-scale program, policy, or project is actually effective. It's all about judging outcomes, providing solid recommendations, and using hard data to guide a high-level decision-making. So, for example, if a city installs a massive, highly expensive new traffic management system, researchers will come in to assess if it actually reduced congestion like it promised. Or in public health, researchers are going to evaluate whether a nationwide vaccination campaign successfully reduced infection rates. They are rigorously measuring effectiveness to support big policy improvements. When we compare these two side by side, the nuance becomes crystal clear. Action research is deeply personal and local. The core question is simply, how can I improve my practice right here in my local setting? Evaluation research, though, is broad and frankly judgmental. The core question is, did this specific large-scale program or policy actually work? So one is a practitioner tinkering with their own daily methods, and the other is an overarching assessment of a huge program's real-world impact.
All right, are you ready? Here is the ultimate cheat sheet.
I highly recommend taking a mental snapshot of this matrix. It is actually kind of surprising how often mainstream media headlines completely mix these up, like they'll confuse a purely theoretical discovery with a ready-to-use consumer product. So whenever you encounter a new study, I want you to ask yourself which of these four questions it's trying to answer. If it's asking, why does this happen, just to gain pure knowledge, it's basic. If it's asking, how can we solve it, to build a practical solution, it's applied. If a professional is asking, how can I improve my practice in their own local setting, it's action. And if someone is asking, did this program work, to judge the effectiveness of a policy, it's evaluation. These four core questions are basically your ultimate decoder ring for the entire world of research. Okay, let's see how well you've got this. Section: which research fits? Let's do some rapid-fire practice cases. Let's put this fresh knowledge into practice. Case number 1. A university studies black holes to understand gravity. Think about the goal here. Are they building a product? Are they testing a city policy? Or are they just trying to expand human knowledge? If you guessed basic research, you hit the nail right on the head. This is a textbook case because the goal here is purely to understand a mind-bending cosmological process without, building an immediate app or application. It falls perfectly into the basic category. All right, moving on to case number 2. Scientists develop solar-powered irrigation systems. Look closely at the verb here, develop. What specific problem are they trying to solve in the real world? Now, what's really interesting about this slide is how perfectly it contrasts with our first case. The answer is applied research. The researchers are taking theoretical knowledge about solar energy and actually transitioning it into a tangible, practical innovation to solve a real-world agricultural problem. They are giving us a practical, working solution. Okay, let's jump straight to our final practice scenario. A city government measures whether a new recycling ordinance actually reduced waste. Think about the scale of this one. It's a city government looking at an ordinance, which is a big policy. And they want to know if it actually reduced waste like they hoped. What specific tool do they need here? And the answer is evaluation research. Huge congratulations if you got that one right. The city is conducting this big overarching assessment of a wide-scale program just to judge its effectiveness. They need that cold, hard data to inform their future decision-making on waste segregation. Wow, we have covered a ton of ground today, transitioning from pure, mind-expanding scientific theory all the way down to localized workplace improvements and broad policy assessments. Understanding how to choose the appropriate type of research ensures that a study's design perfectly matches its expected outcomes. So I want to leave you with this final challenge today. As you go about your week, maybe scrolling through your feed or reading the news, how do the purpose and expected outcome of a study help determine whether it is basic, applied, action, or evaluation research? The very next time you see a flashy headline about a new scientific discovery or a government report, I want you to view it through this new structured lens we just built together. Ask yourself, what is their actual real purpose? Keep analyzing, keep learning, and I will see you in the next explainer.